Welcome to our experiment on mixtures. Today, we'll be exploring the different types of mixtures and how they form. To get started, we'll need to gather a few essential materials. Let's grab a liquid like water, strainer for separation tool, variety of ingredients such as oil, food coloring, sugar, and sand, stick for mixing, and finally, we'll need a container like jar. Now that we have all our materials, let's set them up in a safe and organized place. First mixture, water and food coloring. First, we'll pour some water into our jar. Now, the jar is filled with clear water. Next, we'll add a few drops of food coloring. The drops of food coloring start to spread out and mix with water. Let's use a stick to help it mix faster. Eventually, the food coloring is evenly distributed throughout the water. But what happens if we try to separate them again? Let's use a strainer to see. We see no changes in separating both substances. The mixture is the same. And there you have it, a simple and colorful demonstration of how water and food coloring mix to create a homogeneous mixture or called as solution. A homogeneous mixture is a combination of two or more substances where the components are evenly distributed throughout. This means that the mixture has a uniform appearance and composition. When food coloring is mixed with water, a process known as diffusion occurs. Diffusion is the movement of molecules from higher concentration to lower concentration until equilibrium is reached. In this case, the food coloring molecules disperse in the water, spreading out evenly to create a uniform color throughout the solution. Second mixture, water and oil. The same process from the first mixture, which is we put first a water in a container. Next, we add some oil and gently mix it. As you can see, this mixture is opposite from the first mixture we had earlier. Water and oil don't mix. Even though when we try to separate it, the mixture is the same. Both substances don't mix. Here's why. Water molecules are attracted to each other. They are polar, while oil molecules are attracted to each other. They are non-polar. This difference in attraction means they don't want to mingle, and also because oil is less dense than water. It will always float on top of water, creating a surface layer of oil. Third mixture, water and sand. Again, we put first a water in the container. Next, we put sand and gently mix it. We noticed that the sand went to the bottom of the container. Here's why. The sand particles become suspended in the water, creating a cloudy mixture. This is a suspension, meaning the sand particles are temporarily held up within the water but are not dissolved. Due to the difference in density, which is sand is denser than water, the suspended sand particles start to settle to the bottom of the container. This process is called sedimentation. When you mix water and sand, you create a heterogeneous mixture. This means the components are not evenly distributed and can be easily separated. Fourth and last mixture, water and sugar. For the last time, we put water in the container. Then, we pour some sugar and gently mix it. While mixing, we notice the sugar slowly dissolve in the water. When we separate it, there's no visible sugar particles. This mixture is a homogeneous. Here's why. As the sugar dissolves, it becomes evenly distributed throughout the water, creating a homogeneous mixture. This means you can't visually distinguish between the sugar and water anymore. The process that occurs when you mix water and sugar is called dissolution. Dissolution is the process by which one substance completely mixes with another. Both water and sugar are polar molecules. This means they have a positive and negative end. allowing them to attract each other. And there you have it. We've successfully demonstrated the experiment which highlights the importance of mixtures in different substances in the world of science. We hope you found this presentation very informative. Thank you for listening and watching. Until next time, I am Darling Chusel Muzuye, leaving you this saying, every experiment is a step closer to understanding the universe.